Okay, ultimately when we're solving equations in algebra, we've got to remember that we're trying to get the value of x on its own. So we're trying to get x as the subject of the formula really. Now this first example, I've got 7x plus 5 is equal to 33. And I think to myself, ultimately I'm trying to get x on its own. So looking at this equation, I'm going to actually subtract 5 from each side of the equation, just like this. So I take 5 away from the left hand side and I take 5 away from the right hand side. This gives me 7x is equal to, now 33 take away 5 is 28. Already I picked up a nice clear method mark by getting the 5 eliminated. What I now need to do is to get x on its own, and I need to undo the fact that x is being multiplied by 7. So I'm not going to take away 7 from each side, I'm going to do the opposite of timesing the x by 7. And we will know that the undo function, or the opposite function for multiplication, is division. So effectively what I'm going to do now is I'm going to divide each side by 7. Just like this. I divide that side by 7, I divide this side by 7. And the great news here is that 7x divided by 7 allows me to get 1x, or x on its own. So the 7's effectively cancel. So I've now got x is equal to, or 28 divided by 7 is equal to 4. So I just checked that answer's sensible. I could just pop it into my mind into the original equation. I can see that 7 times 4 is 28, and 28 plus 5 gives me my 33. So I know that x equals 4 is my correct answer. It's a nice, clear, concise method work showing the examiner how you've obtained the correct answer of x equals 4. Now for my second example, I'm going to use a set of brackets. And we have to be ultra careful when we are looking at an equation involving brackets. So what I've got here is I've got a situation where I need to solve two lots of brackets of 3x plus 4 is equal to 38. Now my first progress line would be to actually remove the brackets, to expand the brackets. And I've got to do this really, really carefully. I'm going to multiply the 2 by the 3x, and I'm going to multiply the 2 by the 4. And I've got to be really careful just to make sure that 2 times 3x is actually 6x, so I write 6x there. Sometimes under exam pressure some students write 5x, but remember we're multiplying the 2 by the 3, so that's 6x. When I multiply the 2 by the 4, I get 8. So I have here 6x plus 8 is equal to my 38. So I'm now progressing towards the solution. I'm now going to subtract 8 from each side of the equation. So I put minus 8 here, and I put minus 8 here. And I can see that my next line of progress is that 6x is equal to 30. So I'm almost home and dry with the full marks. I just now need to multiply both sides. So I divide both sides by 6. So I'm going to divide this side by 6. I'm going to divide this side by 6. The 6's cancel on the left hand side, and I get x is equal to, well 30 divided by 6 is 5. So I have a final answer, x is equal to 5. So what I've got here, I can just check mentally that 3 times 5 is 15, 15 plus 4 is 19, and 2 lots of 19 is 38, so I know that x equals 5 must be my correct answer. So if I show clear, concise method work, expand the bracket successfully, manoeuvre a situation, so I try to get x on its own, and I'm going to get full marks for this type of question. For my third equation, I've just got x as a fraction, so x divided by 4 plus 3 is equal to 7. And I think the easiest way forward on this one is just to remove the 3, so I'm going to subtract 3 from this side. I'm also going to take 3 from the right hand side, like that. That gives me x divided by 4 is equal to 4, 7 take away 3 is my 4. And to get x on its own, what I'm now going to do is I'm going to multiply each side by 4. Because x is being divided by 4, I need to undo that. So I'm going to multiply each side by 4, left hand side, right hand side. The great news here is that the 4's cancel, So I can just cancel the 4's, and I'm left with x is equal to 16. And I can see, just by checking my answer, if I just pop 16 into this equation, 16 divided by 4 is 4, and 4 plus 3 gives me 7, so I know that x equals 16 is the correct answer. For my next equation, I have a scenario where I've got unknowns on each side, but I've also got this with brackets. So I've now got to look at this really carefully. It's a more challenging equation. And by expanding the brackets first, what I find here, I've got 3 lots of my 4x, and that gives me 12x. 3 lots of minus 3, so be careful with the minus sign, that gives me minus 9. And then on the right hand side I've got 5 lots of 2x, that gives me 10x. And then I've got 5 lots of 1, that gives me plus 5. So I have a scenario now where I've multiplied the brackets, but I've still got x values on each side of the equation. What I now need to do is to zoom in, or to focus on the smallest number of x's, or the coldest number of x's if you like, and I need to remove that smallest number of x's from each side. So although it's tempting for some students just to manoeuvre and to do something with the minus 9 or the plus 5, I'm actually going to focus on the x's. What I'm actually going to do here is I'm going to subtract 10x from each side of the equation, because the 10x is smaller than the 12x. So it's easier if I just take away 10x from that side, and then I take away 10x from that side. Just like this. There we go. And instantly I can see that significant progress has been made here, because 12x take away 10x gives me my 2x, and 2x take away 9 is going to give me 5. That's really, really good news, because suddenly all the x's appear on just the left hand side, and I'm now almost home and dry. So I'm just going to add 9 to each side of the equation. The examiners always appreciate students showing nice, clear, concise method work. Really nice use of the equal signs and a clear, systematic approach. My next line is that 2x is equal to, well, 9 plus 5 gives me 14. So I've got 2x equal to 14. So my final step is to divide both sides by 2. Divide that by 2. Divide that by 2. And I get an overall answer, x is equal to 7. I'm home and dry. X equals 7 is my correct answer. So in summary, we multiply the brackets first. We still have x's on both sides. We focus on the smallest number of x's, and we eliminate them effectively. Then we get to a scenario where we've only got x on one side, so we then isolate that x. In this case we added 9 to both sides, and we divided by 2, and we came up with an answer of x is equal to 7. So if you stay cool, show clear method work systematically through the problem, there's a very good chance you'll get the full marks on this question. And all the very best to you from the Collins team.